Hello AP Econ class, this is section 14. I'm going to start this video lecture on module 74. We're going to introduce you to externalities. I'm going to just describe some concepts here. You can see the objectives, they're on the screen now. But a couple of concepts are really important to understand. First off, production of goods generates pollution, which ends up being at cost to society. All right, so you got to know that those goods provide a benefit to the consumers, however, who enjoy utility or get some utils from them. A couple other concepts of each additional unit of pollution emitted does impose a cost to society, and that cost is called the marginal social cost. As more pollution is emitted, the marginal social cost, or MSC, rises. Each additional unit of pollution emitted does, however, provide a benefit to society called the marginal social benefit. As more pollution is emitted, the MSB, or marginal social benefit, falls. Okay, now we're looking for optimal, right? You know, where cost, marginal cost equals marginal benefit, right? And that's the same thing here. Socially optimal amount of pollution is the quantity where MSC equals MSB. So, left by itself, however, in an unregulated marketplace, okay, we don't consider the social cost of pollution because the firms are not going to generally consider that. They'll only look at the benefits for themselves, though. So a maximum amount of pollution will be emitted to the point where the marginal social benefit will go to zero. Again, that's unregulated. Firms left to their own auspices, so to speak, and then efficiency can be gained if pollution can be reduced from the quantity produced by the unregulated market to the point where MSC, again, equals MSB. Okay? So it can be gained if pollution can be reduced from the quantity produced at the unregulated market to get back to socially optimal. Okay? And finally, the last concept was Ronald Coase, and the Coase theorem wrote that in terms of externalities and costs, as long as property rights are clearly defined and transaction costs are minimal, a private solution can be found to situations such as the ones just described. However, that does take certain requirements, and there's also a video on the web that sort of goes through that, so I expect you to watch the video. Okay, so let's get going. Let's talk a little bit about the costs and benefits of pollution. So first off, we can see here that, and I stole this right from the book, I'm going to talk about electricity produced in the U.S., and most of it today, anyway, is produced by burning coal. So the electricity is an economic good that does provide quite literally utility to the nation. Okay, so burning coal creates pollutants, however, in the air, water, and soil. So now we got a trade-off. We got a debate. The environmentalists are going to argue, hey, too much pollution, because electricity producers, if they're not regulated, fail to consider the harmful effects of pollution. Producers, on the other hand, of electricity argue that the government regulation unnecessarily burdens them in their ability to produce electricity at the lowest possible cost, which is to say that we're going to hand that over to consumers. So economists, however, see pollution issues as a topic for analysis, right? A cost-benefit analysis, a marginal social cost and a marginal social benefit analysis. And the economists will argue there's an efficiency quantity of pollution where the needs of both the environmentalists and the utility companies are considered. And pollution, like so many other things, both there's costs and benefits associated with it. So first off is marginal social cost, MSC. Okay, the additional costs imposed in society as a result of one more unit of pollution. Okay, these costs include those borne mostly by humans, costs like cancer and asthma and illnesses, or even nature. Loss of species, argue, hey, the crazy spotted frog is gone, or degradation of water, soil, climate, those kind of things, right? And so here's an example of what the marginal social cost curve looks like. It's upward sloping. So if you look at this, when pollution levels are small, nearly zero in this, and if you look at the graph here, the next ton of pollution imposes very little damage to society. Nature can readily absorb it. However, at very high levels of pollution, the next ton of pollution can cause much larger costs to society as nature's capacity to absorb it is greatly diminished. On the other side of that argument is marginal social benefit, MSB. That is the additional benefits received by society as a result of one more unit of pollution. So how can there be benefit from pollution, you may be asking? Well, let's think about this. Think about what it takes to prevent a ton of pollution. So certain industries must use scarce resources, right? Land, labor, capital, entrepreneurship, right? To install new technologies to prevent pollution. These scarce resources have value, and that means that's benefit to alternative uses. Therefore, as we know, there's no free lunch. If we don't use them to prevent a ton of pollution and allow the ton of pollution to exist, we receive that benefit elsewhere in society. So that's one of the ways that economists measure benefit. So therefore, what does this curve look like? Well, it's downward sloping. Again, assume that pollution is completely unabated and pollution levels are very high. At this point, to reduce 1 ton of pollution is extremely easy. This means that the value of the necessary abatement or reduction resources is fairly small. So the benefit of not using them to reduce pollution is kind of small. Let's look at the other way. Suppose we reduce pollution to the point where there's 1 ton of pollution left in society. That's it. We've used all of the easy low-cost, i.e. low-cost stuff, methods to this point. And all that remains is the most costly methods. Again, there's this trade-off, right? So the necessary resources are extremely valuable and taken from other uses. So if we don't use them to reduce pollution, we will enjoy a greater deal of benefit somewhere else, right? So it's very easy to sort of reduce the first ton of pollution and very difficult to reduce the last ton. This means, again, that the benefit of the first ton of pollution is very high and the benefit against the society of the last ton of pollution is very low. So again, now we're looking for equilibrium. The social optimal amount of pollution is shown in this graph as Q optimal, right? QOPT, where MSB equals MSC of the last ton of pollution emitted. So this is the quantity of pollution that makes society as well off as possible when all the costs and benefits of pollution are considered. When society left unregulated come to the optimal point of solution, the question is, will society left unregulated come to the optimal point of pollution? And the answer, according to economists, is in fact no. So why is that so? Well, that's so because, again, there's benefits, both benefits and costs that pollution creates in society. Okay, those who benefit are the producers, right? And consumers of the polluting goods, like forms of electricity in this case. The costs of pollution, however, are imposed on everyone and the natural environment. So this is what this notion of externalities are about. So a consumer of electricity, say in the Ohio River Valley, which is a big deal, certainly benefits from it. Power plant producing electricity certainly benefits. Then since pollution is a byproduct of burning coal, the benefits of the pollution accrue to the consumers and the power plant owners. But there are people living in the east of the Ohio Valley River. They don't receive this benefit, but they receive the pollution from the power plants, right? Some of that particulate matter comes out of the smokestacks and ends up landing in Canada, for instance. And by the way, they've freaked out about this in the past. Or even Northern Europe. This is actually true. There's studies on this. So these people in their environments are not benefiting at all from the electricity, but they're incurring costs. Okay, these costs are external. So that's where we get these externalities. Because the unregulated market does not, really much care about the costs of pollution, the polluting good, electricity in this case, will be produced until the marginal social benefit of the pollution emissions equals zero. This is great. Again, an unregulated market we're only focused on the care of the cost of pollution itself. The polluting good will be produced until the marginal social benefit of the pollution emissions equal to zero. It just makes a lot of logical sense. And the graph, this graph here shows it, and that's Q market, right? This tells us that the unregulated market will produce more pollution that is clearly socially optimal. So how could society do better with less pollution? Again, let's look at the graphs. How can society do better with less pollution? Again, as opposed to the immediate benefiters. Without that externality, we wouldn't worry about it, but we have to. So if you go look at Q market, suppose we could reduce the pollution by, let's just say, 110. What would we lose? Well, since MSB is zero, one last ton of pollution would come out at almost zero sacrifice to society. What would we gain? Since MSC is 1,000, one last ton of pollution would come in and almost, would avoid, nearly 1,000 of harmful costs. Again, society would gain nearly $1,000 of net benefit, relatively speaking, from reducing just one lousy ton of pollution. And this is true, by the way. Look at this range between Q optimal and Q market. That's why I've sort of darkened it out here. Society would gain the shaded area of the triangle between MSC and MSB if pollution could be reduced from Q market down to Q optimal. So that's a really key point of this introduction to externalities, that there's inefficiencies in excesses, and we're trying to get as efficient as possible. So there's a couple of different ways we can solve this problem. We'll get into Mod 75 where we talk about government policies, but for now we're going to go over and talk about our good buddy Ronald Coase, a pretty important economist. And so he basically came up with this pretty cool theorem that maybe a private solution versus a public solution could occur. So let's give an example where, let's say you lived in a house in a beautiful, lovely neighborhood, and it was worth hundreds of thousands of bucks in the real estate market, and the house next door sold, and a new neighbor, Bob, moves in. And Bob proceeds to install a pig pen in the backyard and fills it with pigs. We're talking nasty, smelly pigs. Well, you know what they do, right? If pigs are in somebody's backyard and you're not in that area, if you're in a pretty nice neighborhood, what do you think is going to happen to the value of the property around Bob? Well, the value of the property around Bob, including Bob's property, is going to decline. So if Bob's action causes your property to decline, you're going to be a victim of a negative externality. Okay, so what can you do? Well, you could call the police or some other government office. But is there a way to handle this privately with Bob? And this is what Ronald Coase was saying. He wrote that so long as property rights are clearly defined and transaction costs are minimal, the cost to do the deal, a private solution can be found to a situation such as this. So Coase would say that, hey, these private solutions, if you can internalize the externality, we can deal with it. The party that is imposing the hardship on others is required to compensate the victim. In this case, Bob is sort of doing that. So how can we get together with Bob? In reality, there might be situations where transaction costs are too high to make a private solution, easily negotiated. Well, then Coase's theorem falls apart. That's why, the transaction costs are key. Anyway, so there's also high communication costs, right? High communication costs between affected parties does matter. So suppose that Bob's pigs, for instance, are polluting not just your property, but dozens of other people in the community are feeling the negative impact too, right? Now the cost of negotiating settlement between dozens of people and Bob absolutely become higher. So it's a little more complex. High legal costs could be a barrier. Negotiations and legally binding agreements might require lots of attorneys and huge stack of legal bills. Who's going to pay for that simply because of Bob's pigs? And then finally, there could be costly delays in sort of involved in the bargaining process to begin with. Suppose that Bob is fully aware that you're the victim of this negative externality and decides to delay negotiations and postpones every meeting you've ever decided to schedule. Maybe he thinks that you'll eventually just get tired of this thing and move away. So there's some challenges to the Coase theorem. But at the bottom line, though, he was true. There's ways to actually get together and negotiate. And I think your book actually talks about, Penny Marshall, this director, and somebody was running chainsaws or something. You could walk over there and say, hey, look, we're trying to do something. Do you mind if you stop that? And I will pay you for that. So obviously the property rights are understood. Obviously the transaction costs are reasonable. Both parties agreed, and they stopped. So that's kind of in a nutshell. That's Mod 74. And next we'll get into a little bit of Mod 75.